What we're going to take a look at here is graphing quadratics that are in vertex form. If you remember from our Desmos discovery, what vertex form is y equals a, parentheses, x minus h squared plus k. And the following things are true about this form. When we have the point hk, this point here, and this point here, that makes up our vertex. Remember, the vertex is really the starting point for our quadratics. It's either going to be the minimum value or it's going to be a maximum value. And if you look at our example over here, what that means is this value and this value are going to be our vertex. This value is always going to be our x-coordinate, and this is going to be our y-coordinate. And if we remember, when we look at this, this value is going to flip signs. So our vertex here is really going to be 1, and the y-coordinate would be 3. Okay, so this value stays the same for the y-coordinate. Whatever's on the inside here, x minus something, we'll have a positive number. If it were x plus 1, this would be negative 1. And our axis of symmetry is the vertical line x equals h, which in this case would be x equals 1. And what that means, that there's symmetry across that line. If we remember, our parabola is this shaped. Our axis of symmetry is the line where I have symmetry across that parabola. And we'll take a look at a few examples where to make a little more sense of this. So, taking a look at this, we have y equals 2 times x minus 1 squared plus 3. We know this is a quadratic because of this squared term up here, so we know its basic shape is going to be a parabola. Now, just based off of everything that we did on the last example, our vertex is going to be 1, 3, because this coordinate and this coordinate give us our vertex. We change the sign of this to make it positive. This stays the same, so I'm going to plot the point 1, 3, 1, 1, 2, 3. Here's my vertex. That means I'm going to have an axis of symmetry here, which you guys don't have to go through and draw, but it's good just to kind of see the symmetry. Now, we know this opens up because our a value is positive. That's what tells us there. Is it going to open up or if it opens down? If it is positive, it'll open up, which in this case, it will. Now, what we do, just like any other form, we're going to find one point either on the left side of the vertex or the right side of the vertex. What I'm going to pick is x equals 0, and I'm going to plug that back in to our original equation. So I'm going to plug in 0 anywhere that I see an x, which was only right here. Then I'm going to go through and use PEMDAS. We're going to do the inside of the parentheses first. So I would have negative 1. Now if I remember PEMDAS, I'm going to do an exponent. So I'm going to do this before I even worry about multiplying 2 times this. So I would do negative 1 squared, which is negative 1 times negative 1, which would be positive 1. Now I go through, I have multiplication. That would be 2 plus 3 equals 5. So what that's telling me is when I plug in 0, I have a y-coordinate of 5. I plot that point here, and I should label this 1, 3. I'll label this 0, 5. Now I go through and I actually draw my parabola. So there's half of it there. Remembering that we have this axis of symmetry, so what happens on this side, the same exact thing should happen over here. So at this point, I should have a point right here at 2, 5. So that will give me my parabola. So again, just like every other form, if we find one point on one side, we can figure out a point on the other side as well, because it should be mirror images of each other. If we notice, it is right across and it's 1 away from the axis of symmetry. And really, the same process is going to go throughout this. Now taking a look at this, a few things. Number 1, we know this is going to open down. Our a value is negative. So we should have something that looks like this. That's the shape of our parabola. Our vertex, we're going to look at this point and we're going to look at this point. This is our x-coordinate. This is going to be our y-coordinate. Now remember, for our x, we're on the inside of the parenthesis. The sign's going to flip. So we will be at negative 3. Our y-coordinate will be at 4. Our axis of symmetry is that vertical line that runs through the x-coordinate of our vertex. So looking at all these things, vertex is at 1, 2, 3, 1, 2, 3, 4. Here's my vertex, negative 3, 4. It's going to open down, and then at x equals negative 3. So this line here, no, it's kind of tough to see, but that's going to be where we're going to have symmetry across. Now, just like last time, I'm going to pick a point either directly to the left or directly to the right of the vertex. I'm going to pick x equals negative 2. because it's the x value directly to the right here, and I'm going to plug that into my original value. So I'm going to plug in negative 2 plus 3 squared plus 4, and again go through PEMDAS. Inside of the parentheses first, negative 2 plus 3 would be 1. Now I'm going to do exponent, not worrying about this, negative sign in the front because that is multiplication. So I'll do 1 squared, which would give me 1 plus 4. Now I can worry about this negative. Negative times positive 1 would be negative 1 plus 4. It's going to give me 3. So that means when I plug in the point negative 2, I get a y value of 3, which I can plot right here, negative 2, 3. And I can continue right through my process just like last time. I know this is going to be a parabola shaped, and it's opening down, which we said should be happening. Now, because of this axis of symmetry, we can figure out a point directly on this side. This one was 1 away from the axis of symmetry right here, so right at that same level, I should have a point over here. And I continue my parabola based on that. And I can say this is going to be the point if I look. 1, 2, 3, 4, negative 4, and up 3, so I should have the point negative 4, 3 right there. And that would be my shape. And again, it's just identify the vertex from these points and then use that with the axis of symmetry and find one more point either on the left side or the right side to actually go through and graph this. Alright, here's another example. Okay, and what you can even do is pause the video or move forward in the video until you see the answer, just to check it if you feel comfortable going through and doing this, because I'm going to go through it a little bit quicker. Alright, we know this is going to open down because of the negative a value in the front here. My vertex, I'm going to use this point, and I'm going to use this for my x and y coordinate of my vertex. Just like last time, the x coordinate switches signs, so it would be negative 1. My y coordinate stays the same, it would be negative 2. Axis of symmetry is at the line, x equals negative 1. Plot that point, negative 1, negative 2. Here's my vertex, negative 1, negative 2. I'm going to pick a point either directly to the left or to the right to plug in to find my second point. I'm going to pick x equals 0, just because that's an easy one to plug in. So negative 2, 0 plus 1 squared minus 2. And again, go through PEMDAS here. I'm going to go inside the parentheses first. Now I'm going to do the exponent. Then I'm going to do multiplication. Now I do subtraction. So what that gives me would be the point 0, negative 4. And I'm going to go ahead and I'm going to plot that. 0, 1, 2, 3, 4, right here. So I'm going to draw that. Label this 0, negative 4. And from here, this is my vertex. This is where my parabola starts. So I can go ahead and I can draw that. And just like last time, we have our axis of symmetry running through all values where x equals negative 1 along this line. So I know I can flip that across, have something that looks like this. It should be going through this point of negative 2, negative 4 as well. Again, identify the vertex. Here's your x-coordinate, here's your y-coordinate. Is it opening up or down? Remember, our x-coordinate switches between positive and negative. The sign flips. Then once I have that, I pick one other point off of, on the opposite one of the sides of the axis of symmetry, use that to find a point on the other side, and I'm able to go through and draw my parabola. So, what I want you guys to do for this example, write it down. Okay, you have a little space on your guided notes. I want you to give this a try by pausing the video, and at the end, just look at it and check your work. So go ahead and pause the video now. So if we take a look at what we got here, looking at this example, we have a vertex of negative 3, negative 4, which you're able to identify here and here. Remember, our x-coordinate changes sign, so it becomes negative. Our negative 4 stays the same. We will plot that point. Our axis of symmetry runs through this line here at x equals negative 3. We picked another point off of the line, plotted either right or left. I picked negative 2, plugged in negative 2, figured out my y value would be negative 3 when I took negative 2 and plugged it into my original equation, which gave me this over here. It's supposed to be a 2. And plotted that, used the axis of symmetry to find this point over here, and went through and drew my parabola. That's vertex form.